Welcome everyone. Thank you all for joining us and thank you for signing up. So this is a much anticipated public release of Studio RM 1.4. It includes over 600 bug fixes and over 30 new feature releases. So we have quite a bit of content to get through in the next 30 minutes. So I'll try not to speak too quickly and allow you all to absorb what I'm saying. Okay, so my name is Kathleen Hansmann. Some of you might remember me from prior interactions when I worked for Datamine Africa, and I've recently rejoined the Datamine family as a new role as Global Product Manager for Geology, and I working with the software development team in Wales in the UK. I'm really here to help bridge the gap between the hardcore smart developers and what is practically needed by geologists at mining operations. So Studio RM is an excellent established product for resource modeling. And what we see with this maintenance release is the reinvestment of maintenance back into Studio RM to improve the product that we're all using on a daily basis. Okay, so let's start by looking at some of the core enhancements within Studio RM. So the first thing I want to point out is the stability of a product. So we monitor the crash reports as they all come through, and we have been noticing that the number of crashes has actually come down quite significantly. We've also revamped the crash reporter in the most recent version, and we really implore you to please always use this to help us remove any other instability from the product. Another thing is that this is now only a 64-bit release. For a long time, we ran a 32-bit and a 64-bit installation side by side, and we've now made drawn the line in the sand where we said we're only going to go forward with the 64-bit version. There's huge advantages here, particularly around the performance of large data sets and the ability to quickly load and visualize these really big files. We also have multi-level undo capabilities. This is around your string and your wireframe edits, where it remembers the last 10 edits that you've made and allows you to undo or to redo those. We've also added an extended field name support, and this means that field names are currently 24 characters long, and this is currently an opt-in feature. So let me just quickly show you how to do this. What you do is you come to About Studio RM and you click Manage, and then you can actually choose to use long field names for that particular project. We've in later versions this will become compulsory, but for now it's a choice. And also just be aware of the compatibility issues between moving from a 24-character field name project back to an old project if you have two field names which have the same first few characters. We've also been going through some internal projects to refactor a lot of the old commands. And this mainly has to do with old code sitting inside the software, which is written in languages like Fortran. And what we've been doing is we've been replacing these with more modern code. And what the advantage of this is that there are huge speed improvements. So the commands perform in exactly the same way as they used to. And now but they just run a lot quicker, and I'll actually show you some of these speed enhancements. We've also created some RGB color options, and this has to do with importing of large point clouds which have RGB data and allowing you to view that RGB data inside the 3D window. And we've also been doing ongoing improvements to the data source drivers. So some of those improvements include updates to the Vulkan and the Micromine drivers, as well as inclusion of Acquire 64-bit drivers and new PDAL drivers. So what PDAL is it's a driver for importing large LAS data sets. So these are the types of data sets which drones produce, maybe LiDAR and CMS and other automated survey systems. So this is when you want to bring in files that are several gigabytes in size, or maybe up to several gigabytes in size, and it actually allows you to filter those at the time of importing. So instead of having to bring in a 10 gigabyte data set, you can choose to decluster that at the point of importing, so it only brings in as much data as you need to sort of, improve the performance. We've also allowed the Fusion 32-bit drivers to be enabled under the 64-bit release. And this is really good news for clients who are running scripts which retrieve that data, and previously those wouldn't run in the 64-bit version. Okay, here's a quick slide of some of the speed improvements. So these speed improvements are since the first version of Studio RM, but you can see, I mean, there's really some massive improvements to some of the core processes like your AdMod, your CellWF, and some of the interactive processes like your generate outlines and merge selected strings. So here I'm going to run through some of the more specific changes to Studio RM. And when I say that, the previous changes which I've discussed are all core changes, which are common across all of Datamine software products, not just Studio RM, whereas these are specific to RM. So the first change are to the drill hole visualization. So what we've allowed is multiple types of views to be allowed down the hole at the same time. So what this means is you can have a look at perhaps labels and downhole histograms, which might be lines and or bar charts at the same time. And also we've allowed 3D referencing of downhole core images. So how this works, we have a drill hole file and you would like to look at some core images. It's as simple as creating a table of those image names, which could be related to files on a server or files on your local computer. You desurvey that file with your drill hole file, and then you insert it as an additional column. And then you can actually view those image files along with the core. We also have a pretty useful command that we've added in here, which is write select to drill holes. So you can select a series of drill holes, and using WRD, you can just save that subset of drill holes to a file. Okay, we've also started on our journey of implicit modeling. And with that, I'd like to show you some of the other new wireframe tools that we've created. So we've created a tool for the surface cloud reconstruction. So having a look at a particularly complex underground cavity. So what this does is this allows you to generate a wireframe around a point cloud. So this would be something that you would import using the PDL drivers. And then we end up creating a wireframe around these points. So the first thing that we would do is we reduce the number of points. So here we have 33,000 points in this cavity. But what I'm going to do is I'm going to reduce it to 29,000 and choose to decluster it. And what this does is it removes the points which are outliers, which are probably errors in the actual survey process. Then what we do is we check that these points are all perpendicular. So here, what we're doing is we're looking at the point cloud and we're ensuring that all of these arrows are pointing outwards. Occasionally, when you have a very complex shape, or there might be a hole because the survey system was unable to sort of look around a corner, the systems find it a little bit difficult to understand what is inside and outside. So you can actually just come digitize some strings which represent what is inside, and the system will use those strings to sort of get that logic right. So once you have these sort of normals pointing outwards, we can then come and create a wireframe. And it's really quick. Okay, so if you come look at the back of this, it's a foot shape, you can actually see how some of these, the points are extending here, but the surface has actually been interpreted as coming flat. And that's sort of what the surfacing algorithm does here. There's also a secondary surfacing algorithm, which is Gaussian create from points. And that's for even more complex shapes than this one that I've shown here. So carrying on from the surface reconstruction, I'm going to start talking about implicit modeling. So the first thing which we've built are some interactive draw hole attribute editing tools. So what these allow you to do is to take particular attributes which may have been logged. Perhaps you've logged several different rock types, and you would then like to interactively merge those into broader categories, which you then will use for modeling. The second process, so that's your group lithologies. The second is assign lithologies, which allows you to recode drill holes. Perhaps a particular unit's been logged as a one rock type, but then when you actually look at it and start interpreting your data, you might deem that it should be overwritten with another rock type for your interpretation. So this allows you to interactively recode those sections of drill holes in the 3D window. Then the first tool that we've built is vein modeling. So what this does is it looks at your data and it's able to determine what your footwall and hanging wall contacts are, and then actually auto-generate a surface for that particular rock type unit. And one of the real strengths of this is that we've incorporated this idea of uncertainty. So if you have a particular drill hole set which you trust completely, perhaps it's diamond drilling, you might give that drill hole set an uncertainty of 0. But then you might have a secondary data set which could be historic data, or it could have been drilled with a poorer method, like perhaps blast hole drilling with some kind of lithological contacts in it. And you don't trust that data set as much, maybe because of a poor survey method or because of poor logging standards. So then you could set an uncertainty to that secondary data set, but use them together in your modeling process with that uncertainty field reflected. Obviously, if you were to set a higher uncertainty on your data set, it's going to generally create your surfaces quite a bit quicker. And if you set no uncertainty, it's going to treat all your data as absolute and respect every single contact completely. And it will actually insert points at each of those at each of the drill hole intercepts. So there's absolutely no question of where that contact lies. So this is actually only the first step in what Datamine are doing in implicit modeling. And we have some really big plans of what's coming later, sort of modeling of multiple veins together, modeling of more blobby type ore bodies, looking at grade shell modeling, and introducing of geological sequencing. Also having some commands for smart compositing and inverting of boreholes. I mean, it's really a big development plan, and this is what we've released in 1.4 is pretty powerful, but it is only the first step. We have made the decision to release some commands which aren't yet ready. And this is really for users who are excited and would like to try out some things. So please, by all means, try out some of these additional commands and let us know what you think and what your feedback is, and we can incorporate that into what we do down the line. So let me actually show you how easy this is. I've got a particular vein here, which we going to look at modeling. So here we've used some of the tools to reassign drill hole composites and actually set the attributes in this vein. And as you can see, it's quite an irregular mesh of drill holes. So what we're going to do is you can specify what your continuity is, which is basically how much you would like those surfaces to extend. And we have various other options here for what the resolution of the surface you create is, whether you would like it to pinch out which surfaces, a footwall or hanging wall you want created, what your default uncertainty is. And generally the defaults are pretty good at picking up a surface, but occasionally you will need to tweak those to produce something which is a bit better. So here we very quickly produced a upper and lower surface for this vein. And then you can also immediately look at what the thickness of this vein is and sort of play around to get it a bit more accurate. The next thing I'd like to look at is the interactive contouring. So this is different from implicit modeling in that this is an interpolation method. It's ideally meant for a quick interpolation of 2D scattered data. For example, if you have a geochemical sampling program and you have 2D data with various X and Y values, and you would like to create a quick 2D model of that, you can use it. You can also use it in 3D in terms of if you have drill holes and you would like to create a surface, perhaps you have a lower oxidation profile that you would like to pick up, and you would like it to reflect all of your drill hole contacts, but interpolate what's going on in between. You could use that for this. So, sorry, let me have a look at this. So here we're going to generate some contours. So we generate contours from drill hole intercepts. This was also built in conjunction with a company called Petrosys, who are another parent company under the company who own Datamine. Sorry. I'm going to select a particular stratum. So we'll look at the S4, which is one of the units found in these drill holes. You also got a couple options here to use a search ellipse. Perhaps you've identified that there's a trend in your data and you would like that trend to get reflected in the estimation algorithm, and some options for the type of estimation you would like. There are different estimators, some of which will completely respect your drill hole data, and others which may create an average over a particular grid. And I'm going to create an output surface. So this has actually created a wireframe of those, which honors each of the points in each of the contact points, and it's also created some contours. Okay. The next section I'm going to talk about is what's happened in the Advanced Geostatistics module inside Studio RM. So Studio has always been it is and it always has been a resource modeling package. So one of the strengths there is the estimation algorithm. So as many of you will be aware, we introduced the Advanced Geostatistics module a couple of years ago, and this was in conjunction with geovariances. So the massive strength of this is that the estimation is significantly faster than what we see in the old and stable and trusted Estima. So with CoCrig, which is the process that backs the Advanced Geostatistics, CoCrig also allows you to do co-crigging and generate your cross-varograms very quickly. So let me quickly run through. I'm not going to run through the module in its entirety. I'm just going to quickly point out what we have improved in the most recent version. Uniform conditioning is also part of this module, and we've now enabled the co-crig as the estimation method behind uniform conditioning, which means it's a lot quicker than it used to be. Under the variography, we've done massive improvements to the anisotropy identification. So what you can do here is you can now actually you can play with these legend categories and adjust where the sill is and where these thresholds are so that you can more easily see a pattern. Also, these windows have also been labeled and colored. So when you're looking at a 3D deposit, you can actually more quickly pick up which window is which. And you can also see your sample data set. It's not so clear as these samples are points, but the particular domain that I'm looking at, those samples have been filtered and are viewed along with the anisotropy. As very often your drilling grid may also influence what the anisotropy is, as you may have drilled along that particular pattern. We also have some auto-fitting tools as well. We can actually allow the system to help you determine what anisotropy it picks up. We've also done a lot of, through various parts of this workflow, we've actually focused on the speed, like allowing sort of removing the automatic statistics generation and moving those to a button. So when you start the module, it's sort of a bit quicker to load up your data file. We, for the varograms, we've added in something which was very necessary. We allow normal score varograms. So just with a tick box, you can look at your normal score varograms, and also all the back transformations are in there. So particularly for nuggety deposits, and sometimes when your varogram is not displaying very good structure, it's a bit easier to look at the normal scores instead. That's all under to revert from a normal score to an ordinary space varogram. You actually do it here under the Fit Models window, and you back transform it there. Under the K&A, we now save the location of the well-informed, moderately, and sparsely informed points, and you can actually see those points reflected in your 3D window. And for the K&A itself, you can sort of switch between different K&A iterations by using this control panel at the in the bottom corner here. And you can also view those files in the table editor immediately. So you can sort of use that data and see what all the different tests that you've run previously are. Under the estimate, we now allow for rectangular search ellipses. And we also, in the field names that you set up, you can also now see the number of drill holes as well as the number of samples that are used for that particular estimate. The other thing which we've done is we've enabled all of the processes which are used behind the scenes to be used as batch processes. I mean, Datamine's always had the strength of allowing you to have your own processes and your own scripts and macros which control these. So, you can pick up the CoCrig process behind the scenes and all of the K&A and variography mapping processes as well. Another feature which I'm pretty fond of, we've allowed for the SAMP out file, which also gets created through the it can get created through the advanced estimation window or through your estimate, but you can actually visualize this file now in 3D. So using the estimate show samples, as I click on different blocks of an estimate, it's actually automatically filtering the samples which were used in the estimation of those blocks. So this is really useful for once you've run your estimate, if you're unsure why a grade of a particular block might be too high, you can actually look at the weighting of the samples assigned to that block and actually see perhaps your neighborhood was a bit ill-defined, or just help you to optimize that particular estimate. We've been refactoring all of the evaluation commands. So if you now run the old evaluation commands like EV1, EV2, EVA, these now use the same engine as all of the other evaluation tools within the software. So when you run EVA, it picks up an interface and actually runs that. So it's more interactive rather than running as a process which sort of produced a screen output like it used to in Studio 3. We've also included a process for cut and fill volumes. So this is really useful, and this is also one of the advantages of Datamine having so many different products which sit on the same common code base. We built this cut and fill functionality primarily for Studio OP, and it allows you to look at models between surfaces and to evaluate those models. And since it was such useful functionality, we decided to just enable it inside Studio RM. So we all get the advantage of the development which was done for sort of brother and sister software packages. We've also added in a couple new and improved processes. So let me quickly run through those. The StatCom process is actually stats comparison. So it's a validation tool for when you're doing your estimates, and it compares a drill hole file to a sample file by domain. And it produces an output inside Excel, which looks at your mean grade, your declustered grade, and your model grade. So we're looking at this chart in the bottom left here, and you can see here for various domains how those particular grades compare to see if your model is valid for those particular domains. We've also added in some Excel outputs for some other processes, like when you run a swath plot. Now you get an automatic swath plot produced in Excel. If you run ton grade, you also see an output in Excel. There's a new process called Grid DC, which is used for optimizing your declustering grid size. So it uses a wandering mean method of analyzing different grid sizes to determine where your lowest mean value will be, so you know what to decluster as. Also looking at some improvements to some existing processes. There's some big speed improvements to reblock and to ProMod as well, where this will now run quite a bit quicker than it used to. Okay, we're starting to get to our 30-minute marker. So there's one last thing I just want to talk about, which is Freshdesk. So we've had quite a big think over the years about how to consolidate a lot of the documentation and the tutorials, and also a lot of the information on scripting and on macros. And we've actually used this, we've used a platform called Freshdesk, which is a support platform. And we really implore you guys all to sign up to Freshdesk, and you can sort of get involved in the conversation there and have a look at all the documentation that we've provided. So using this link here, datamine.freshdesk.com, to EN support sign up. And if you don't have access to this link, you can also just contact your local office and they'll be able to send you this. So please, if you can sign up to that, and then you can see all the documents, and those are all available to you. I think, yeah, here we go. Here's sort of an overview of the type of documents that you can pick up here. And you can also run and manage support through here, through this platform as well. Okay, thank you all very much. I'm happy to take a few questions. Okay, does it require a different license? No, it doesn't. All of the implicit modeling is part of the standard Studio RM. All of the, I think this question is specifically about the points, the surface from points. No, it absolutely doesn't require a separate license. I know that there used to be an old implementation of a similar tool which did require a third-party license, but no, that's been totally taken away, and this is all available to you under maintenance. There was a question in the earlier presentation, and that was about the RGB colors. I just want to quickly show you what I showed them in the earlier presentation. So with the RGB colors, that how this works is that when you import data from particularly large point clouds, there's very often an RGB color, which is a red, green, blue color, which is associated with that point. And what we've done is we've actually enabled you to view those points. So you can actually, under the data properties, you can actually select RGB color, and that reflects colors in a particular column. And then those colors are then viewed. So when you look at this particular point cloud of an old volcano of St. Helens, you can actually see the colors reflected. So it looks like a surface from afar, but as you zoom up, you actually realize these are just individual points with RGB colors. Sorry, there's a question here from Logan. I have a question regarding the point cloud surface construction. When converting a point cloud to a wireframe, what would be your strategy for adding a texture to that wireframe? I don't know if we could particularly add a texture. There is actually development which is ongoing, which is going to allow, it's going to be quite big changes coming to wireframes. And this really has to do with allowing OBJ and PLY objects, which are wireframe textures, to actually be visible. So in RM 1.5, those will actually be enabled. And those are also compatible with all the Microsoft products, sort of exporting those to PowerPoint or other Microsoft products. But for now, I mean, you don't really get particular textures of the wireframes. You would only get sort of colors of points. Hope that answers the question, Logan. Thank you all very much for your time and for joining us. And if there's anything else you'd like to know, please feel free to get in touch and send us an email, and we'll get back to you on those. Thank you.